Okay, so we got the post code where we want it, right? We were able to save this operation comment and output it after, if we look back at this code here, and output it after this tool call right here and the insert information. Now, what if we wanted it after the G54? Well, now that we've separated it, that's when it gives us that flexibility in order for us to move it around. So if I want this in a different spot, now I'll go down after the WCS call, and I'll pop it in down here. Let's just put a little extra line in here to kind of separate the output a little bit. So now by moving that code down below that other section, I've now moved the operation comment below the work offset. All right, so that's what, this class is kind of about, is getting that flexibility to be able to understand what's creating the code, where it's coming from via Mastercam, either by way of the NCI file or by using user-defined variables and parameter read functions to go get the data that we want to get. Let's get back to the debugger. I didn't close the debugging session on purpose. Leaving the debugger open allows you to run multiple sessions and see the changes in the NC output in the debugging process. So I'll come back into Mastercam, select the operations, hit post, and then hit the debug button again. We're going to go back to the debugger. And right now, the posting process is paused. It is waiting for me. You can see that pprep is highlighted in black. pprep is the absolute first post block that will automatically be called by MPDLL. It is a pre-processed post block. It allows post instructions after the post is parsed, but the NC file is not yet open. What are we doing in here? We are reading control definition, machine definition, and toolpath group parameters. We are setting variable values. That's exactly what we're doing. Now, the posting process is really kind of involved, right? Like when we process RDCD, this command right here, we're going to go read all of the CD parameters. The parameter data in Mastercam is stored in different sets of numeric variables. If I go back to the documentation and we go look at the parameter reference, and you look here, you can see new and change parameters, operation and toolpath parameters, machine definition parameters, control definition parameters, machine group parameters. Traditionally, operation parameters have had the most values. It's 10,000 through 19,999, which is 20. It's about 10,000 numbers. Now the 30 and 40,000 series, and actually 60,000, 65,000, and 70,000 series are being used. So we're talking about the parameter number where we're storing data. Control definition parameters are basically 17,000 to 18,000. And machine definitions are between 18 and 19,000. And the machine group parameters are between 19 and 20,000. So there's basically a range of, 1,000 different parameters available for machine definition, control definition, and machine group parameters. In the parameter reference, we talk about how to go get that data. It's talking about new and changed parameter numbers. And so what is a parameter? When you look on every dialog box in Mastercam, every data entry field, every drop-down box, every place where you can enter data gets stored somewhere. A lot of that gets stored as an actual numeric value. So when we're processing lathe face parameters, there's a default Z coordinate, which is new for 2017. That value gets stored in parameter code 13,721, 13721. When we go down and look at lathe parameters, here's a lathe roughing operation. Okay, use equal steps, true or false. Anything that's true or false is going to be a 1 or 0. So 1 for true, 0 for false. Step amount. Okay, so when you look at your lathe rough operation, the step that tool is taking, which was value 10,200, 10200, is now 13,343. Plunge move feed rate is parameter number 10221. So as you go down and look through, here's lathe roughing toolpaths. Lathe contouring, lathe cutoff, lathe plunge. So basically every control in Mastercam. Here's one, tool width compensation. If it's set to use tool width, 10.0125 is going to be equal to 1. If it's set to use plunge clearance angle, 10.0125 is going to be equal to 0. Now, are you going to want to know which one of these radio buttons is set when you're processing a toolpath? I don't know. But the point is, it doesn't matter because somebody may want this data at some point and it's available to you. You may not want this data, but if we go and look at the tool parameters and we go look at the insert, I guarantee you're going to want some of that data. That data is useful, right? So machine definition, control definition, toolpath group parameters. Let's go see if we do this. So this is like lathe tool parameter stuff. Yeah, op tool info. So some parameter numbers are grouped together as part of sets of common parameters that are all used together. Some of them are going to be specific to an individual toolpath. So sometimes it can be a little tough to know which parameter number you actually want to go get. So like tool settings, right? A lot of these are going to be a universal parameter number. Doesn't matter whether you're in mill or lathe or router or mill turn, it's going to be the same number. But some of them are going to be very specific. So sometimes you just have to kind of search through it. We'll just keep searching. Insert, tool insert corner radius, tool insert width, tool clearance data, tool insert height. So that's all tool clearance stuff. Insert back rake angle in radians. Insert front rake angle in radians, tool center position. So a lot of this data is available to you. You just have to kind of know where to go get it. Spot drill stuff. So tool insert corner radius. Now sometimes you can Yeah, sometimes you can expand the bookmark and go in there and look for a specific tool path, but what we're really looking for is tool parameters. Now, there are some techniques that you can do for looking for a specific parameter as well. So we'll get back to parameters in a little bit. Let's continue talking about using the debugger. Right now the posting process is paused. It is waiting for us to do something. If we go to debug, this debugger has got some useful functionality. Breakpoints are awesome, which allow you to set a stop point. Variable watches show you the current and previous value of a variable and tell you whether a variable has been output or not. There is some functionality, step over, step into, step statement, that has been broken for a long time. Step over and step into are supposed to allow you to ignore jumps or explicitly go into a subroutine. They haven't worked for a long time. Don't even bother trying to use them. Step statement is the only one that really works. And step statement tells MPDLL to process the post-processing process one statement at a time, one step at a time. If we start using step statement right now, we would be here forever because we've got to process thousands of parameters just to even start getting to p header. Because what ends up happening is, that's one of the things there is that step over and step into are deceiving because it's like they should work, but when they so basically CNC Software bought a commercial copy of a debugging engine and hooked it up to MPDLL to give us this debugger, and they're not interested in putting in any more, really much more. Well, I shouldn't say that, but the last time I talked with them, they weren't planning to fix this. Part of that is because even though MP language is continually enhanced, exactly. They should think about at least changing the interface and removing them if they don't work. And that's maybe something they could do rather than spending the hours to actually try to hook them up. That wouldn't be a bad idea on their part. Part of the reason they're not investing time into this debugger, Mastercam posting and post language is kind of at a crossroads. For the longest time, we have had the MP language, which has been Mastercam's homegrown language for mill, lathe, router, wire processing. With the creation of mill turn, Mastercam CNC Software needed a new development platform to be able to allow communication between the simulation configuration and the back end of Mastercam. What they came up with was MP.NET, which uses Mastercam extensions to drive the simulation. Inside the simulation, you choose functionality from what they call tokens. So, for example, maybe you're syncing operations. The Mastercam Sync Manager, all that stuff for MT is built in with MP.NET. That functionality is going to be what Mastercam will use for their posts in the future. The problem is we're talking the future is at least 10 years away. So they will be developing MT and the MP.NET language for at least 5 to 10 years. Which is why we have MP, which is their older language, and MP.NET is proprietary and locked down. In order to be able to even edit one of their posts, you have to have a developer's license, and basically it means you have to be a developer partner with CNC Software. It means that for people wanting to use MP.NET, it won't be an open language the way that MP is currently. Now, I don't know if that's going to be their future plan. They may decide to open it up at some point, but it's about them developing their proprietary platform to drive MT and then making it drive simulation for all of Mastercam and integrating everything in. And it's a great promise, but you know, if we're 10 years away from having it fully done in MT, then we're probably 15 years away from them converting over all of their existing legacy stuff. And then the question becomes, what do all these people that have spent all this money on all these custom posts over the years do? Because in order to go to the new platform, the post is either going to have to be completely, well, it's basically going to have to be completely rewritten, because the design of the MP.NET is just way different in terms of coding and processing. So, you know, I'm sure there will be a ton of functionality that'll make things in some ways easier, but I also see it as being probably functionality that by the time it's mature, I'll be ready to retire. I mean, quite honestly. So there is still the thing about MP, what we're learning is it's applicable today. I can go out and I can write a post for just about any machine except a complex multi-spindle or multi-turret, multi-spindle, you know, 5, 7, 9, 11 axis machining center. So as long as we're driving a dual spindle, dual turret, 4-axis machine, no problem. Mastercam lathe will handle that quite well today. You just need to have things customized. So, you know, I look at the skills for MP, what we're learning, as being very practical. I mean, it's stuff that we can do right now to fix all of the posts in our shop. And quite frankly, you know, MP.NET has its place for what they're doing for MT, but if they're not going to share that with everybody, if they're going to try and keep it locked up and charge everybody for it, I just, I don't know. I think what we have available to us right now is completely awesome, because they do let everybody, you know, have copies of the documentation, learn the language, you know, teach classes, all that stuff. One of the things they are doing for 2018, Cade brings this up, they are starting to finally hook up some of the machine definition stuff. So for years, we've had these kind of old generic posts that have been hanging around inside Mastercam, where the configuration of the post was done by setting variables at the top of the post. This is especially true for the 5-axis. And now they're actually hooking up some predefined variables to go in and read the settings from the machine definition to allow you to more easily configure and set up a 5-axis machine actually using the machine definition, which is kind of new. And there is a whole new mechanism for processing tool table data. So they did some really cool stuff with that. If you want to read about it, in the new documentation, it is working with tool and operation parameters application guide and working with enhanced tool table application guide. So this goes through what it takes to convert an existing post from the pre-processing mechanism to generate a tool table to the new functionality, which is the enhanced tool table data. There's a ton of really useful stuff in here. And combine that with this guy working with tool and operation parameters. So some stuff here, direct access to machine definition data. This is what we were talking about for the kind of the changes for 2017, 2018. So there's this MP advanced functions. And this stuff is all well and good. But honestly, before you even get to this stuff, we really got to get through the basics. Because you got to be able, you know, in order to start playing around with the new stuff, you got to know how to create sets of variables and fill them with data, and how the all of the string functions work, how all of the parameter read logic works, how to write logic. So we got a ton of stuff to get to before we get to some more of these advanced things. But this is the kind of stuff that we'll be playing around with a lot in office hours, adding code to the post to go in and read parameters, build strings, output them to the NC file. All right. As we're looking at the debugger, we still need to press play. You'll notice with the NC code, it says NC output 2. So NC output 1 was what we just did. That was the first time we ran the debugger. Now we're going to process NC output 2. If I go to the debug menu, you'll notice we have some commands here. Run, run step, run turbo. If I go look at configuration, show expanded NC output is important when we run the post. And you want to make sure the trace is turned on. These should be on by default. So trace and show expanded NC output. All I'm going to do now is play. So before I did debug, run turbo. Now I'm just going to play. I haven't set any breakpoints. I haven't done anything else. So it's going to play through the debugger. It's going to output my code to the text editor. If I look at the debugger window now, and we compare output 1 and output 2, oh, it won't do that for here, will it? No. Okay, so output 1, for every line of output, you can see that you've got this little arrow character, little dash with the right character arrow. So set jaws, chuck pressure at 300, live tool, M1. Here's this complete line. So this line is made up of N100, T0909, and a comment that says rough face and turn. So you can see right here, says it's coming from LSOF. This is in NC output 1. If we go to NC output 2, for almost every line that we're outputting, you can see that there are actually multiple lines, and this shows the line being built parameter by parameter. So if we look at this NC output, let's get rid of some of these that we don't need for the moment. Okay, so if I go click on the percent sign, it shows P header custom. If I go click on 0600 here, you can see that we're actually in P header custom, and it shows program number here highlighted in bold. It's hard to see the highlight because this whole line is highlighted, but this is actually kind of in highlighted text right here for program number. Now on the next line, you notice we have 0600 with the open parenthesis. If I click here, double click it, it shows that scom str is the actual variable that output this character right here, which is the open parenthesis. Now we output this string. So if I double click here, it shows the S program name $. So can you see that? I'm clicking on this guy right here, this line, and the only thing that was added from here was this string, partno dash 100 600 rev a underscore test dash 2. The next line down adds the close parenthesis, which tells me it's scom end. And then you notice the output right here. You see the little arrow? That means that $$ wrote that line. So there we finished that output. Now if I click on description housing, you can see that this is coming from a manual entry. It's coming from the scom string from G-code 1006. You notice that the comment, or that the output here says it's coming from P comment 2, and it was originating in P header. So all of this is my manual entry being processed. Okay, because you can see it's coming from P header custom, P comment plus P comment 2. It's showing the progression of calls through the post blocks that output this. Then we get to our first line from LSOF, which says N100. So if I double click that, you can see inside L tool change, N $ is where that N100 came from. Then we built TO909. That came from the tool number variable. You can see it right here. We're still in L tool change. What comes next? We just processed tool now, which is this guy right here. Next is the open parenthesis. Now what do you see right here on this line after asterisk tool no? The next block is not a variable. The next block is a post block call, and you can see it right here. P tool comment. The building of this comment string, including the open and close parenthesis characters, happens outside of this line. This call right here is a jump. And that's one of the hardest things to wrap your head around when you're watching the processing of MP. We're processing L tool change. We're processing it because it was called as part of LSOF. We're still in the start of file. So we're at the top of the NCI data. We're processing the first tool change as part of the start of file code. We've gotten down through here. We've hit the tool number. If I click on the open parenthesis, you can see we've now jumped. And we've jumped into the P tool comment post block. So this post block is the comment for tool. This is where we build and assemble the string that's going to be output. So here's where we can add code to add data that we go get from parameters. So if we want to add the insert type, the insert name, the manufacturer's tool code, the EDP number, the stock number, whatever your tool crib code is, whatever data it is, there's usually a place to enter it in the Mastercam interface, and then we can go extract it through a parameter. So all of this output here, you can see here, scom start, here's the tool string, here's the insert string, here's the insert to string, and here's the end, scom end, which is closed parenthesis. So running the post turbo shows us line by line, but it only basically shows us where the start of the output was assembled from. Running it without running turbo, so just running it through with expanded NC output turned on and trace turned on, really can show us statement by statement how this is getting built up. If we go down to G99 down here, you can see that G99 was created by SG feed. So that's where the actual variable got output to output the G99, but what called it? Well, if we go click here on the N130, here's the line that actually output it. PBLD, N $, PF, SG plane, PF, SG feed. Whenever we're working with a post block, this is a post block call. It means we're going to go jump to wherever pspindle is and execute all of the code in pspindle. That may or may not create output. A lot of times a post block like this will be calculated just to calculate values. Pcan is for can text before the tool change. So if we had enabled some kind of can text option, it would be output here. pcom_move_b is a setup post block. pcom_move_b in general calculates values before the tool change or before the move. pcom_move before. Okay, so now we've ran the post turbo and we've ran the post through by just playing it. Now let's take some output that we're actually interested in and see how it's getting built. Okay. So how about this guy here with this line of code? So if I go click on this line of code, it takes me to this line in the post, which is part of L tool change. Yeah, this one's part of L tool change. So let's say that I'm interested in this line of code. I'm interested in this M621 for my coolant. I know if I click on that again, if I click on the sequence number especially, since sequence number is output by a variable, not by a post block, generally that's going to be on your output line. It's a pretty safe bet. So I want to be able to stop the post before I get to this output line so I can check out data. So I'm going to go to this if line right here in my post, and I'm going to set a breakpoint. So I'll select if home type equals, or if home type greater than 1, and hit the breakpoint button. So that should have inserted, and for some reason I don't know why it kind of jumps around a little bit sometimes like that. So if I go back, P comments, header, L tool change, there's my double arrow. So you can see I've got my breakpoint set. So now what I'm going to do, let me reorganize my windows a little bit here. I'll make my NC code pretty wide so that I can see all my info here. We'll bring the post down here. And we've got our NCI code as well. Okay, so I've set my breakpoint. And I'll go back into Mastercam, select the data, and repost, debug. In the debugger, we should be ready for NC output 3, and I'll hit play. And the debugger is going to run until it hits my breakpoint. So you can see that the process is now paused. I'm at the MO4, so this isn't... If I go process the next line, let's see here. Yeah, this is the first operation anyway. It was actually a different operation. It was down here that I was interested. So that's the boring bar. So that's another tool change. So what I can do now is hit play again. And it's actually going to run through the output after this until the next time it hits this breakpoint, if this post block gets called again. Because it's L tool change, it probably will get called again. So we'll hit play. Oh, and play again. There we go. So now it's going to process everything in between the T0909, which was this line here. So it processes the next operation. And then we get down here to the rough bore bar. And we're paused again at the last output line, which was here. And we're here. If home type is greater than 1, absinc equals 0. Well, now we're going to process this line down here. And we want to know what's going to be output. So this is where this other window comes in. We're going to go to View, Watch. So the watch window, and for now I'll stick my NCI behind my NC for now. The watch window allows us to set a variable watch. What is a watch? This allows you to see the current value of a variable and the previous value of a variable. So, for example, we've got some post blocks in here that do some different things. The problem is you can only watch a variable. You can't watch a post block. So we'll have to do this in a little bit interesting. What I'm going to do is try to highlight $N$ here. You have to be careful with the variable you grab. I don't know if the comma will work. So I'm going to go up here and hit add watch. Yep. So I was able to grab $N$ and it shows me previous $N$. Now what I'm going to do over here is grab, see, SG code is a string select variable. We'll talk about how that works as well. But what we'll do is we'll just process this one at a time. I know string can text is a variable, so I am going to put a watch on that. And what we'll do is start using step statement. So unfortunately, step statement's the only one here that works. So if home type is greater than 1 is true, so we're going to set absinc equal to 0. And absinc is actually a variable we can watch, so I'll put a watch on that. Now, if you want a specific variable, but you don't have it here to highlight in the list, you can actually just click add watch, and it'll bring up this variable watch name entry right here, and you can just type it in. So for example, I know if we go up in our post a little bit, that we have some variables that are going to be used at some point. All of these should be used. So I'll hit add watch, X abs, okay, add watch, Y abs, add watch, Z abs. Okay, you can see that we're adding each one of these to the list. Add watch. I think it's X Inc. Okay, so I'm adding each one of these. Try and make it. Sometimes you can change the size here. There we go. And get it to resize the window just a little bit. There we go. Okay, so X abs, Y abs, Z abs, X Inc, Y Inc, Z Inc. C abs, C Inc is probably a good one. So we'll do C abs, C Inc. And we could do these for circles as well. The point of this being, the way that Mastercam determines which values are going to be output when it comes to motion has to do with a thing called modality. A modality asks us, is the previous value of the variable different from the current value? In this case, our Z value is going to be output because there's a difference. Look at Y abs. Y absolute is 0, previous is 0. It's not going to be output because there's no difference. That makes sense because it's a lathe, but if you look at X abs, current value is 3.3645, blah, blah, blah. Previous value was 4.529. So, we've got some variables set that we're going to watch. And we'll do basically single block, which is step statement. So we've processed the line above. Now we're going to process pcan1. So I hit step statement. You notice that it calls pcan1, can text with move. So now we're going to start processing each line of code in pcan1. Look at the first line we hit. String can text equals S blank. I'm surprised it's not showing us the current value of string can text. Let me try to do it this way. Ooh. No, still not giving us it right. So I'll hit step statement. So if cstop, well, string can text equals that, blah, blah, blah. Okay, so nothing is output there from pcan1. Now we jump to pbld. Because remember, pbld block delete is a post block call. So we jump. You can see that pbld says if bld. So if we put a watch on bld, I don't know why we're getting this server error on there. It's interesting. We do step statement, so that's not true. And $, and you can see that for output 3, we've written our sequence number to the output. So that actually got output. And you can see, look at it now. The current value is 290. The previous value is 290. It just was output. Okay. Single step statement again. We just processed our SG code. Now we're going to hit PFX out. So we hit step statement and we jump to PFX out. So if absinc equals 0, we're going to output xabs. We're going to force it and we're going to update xinc. Else, we're going to force xinc and we're going to update xabs. So what's the condition that kicks off this output right here? If absinc equals 0. Look at your watch list. You've got absinc right here. Absinc is equal to 0. So what do you think that's going to be? This is going to be true. So let's process it. I hit step statement and we jump to if absinc equals 0. I hit step statement and you notice that it jumps to the result. It jumps to the result because the value was true. If absinc equals 0 was true. So now we're going to output xabs and then we're going to update xinc. So you can see xinc over here. I'll hit step statement and you notice they both get set to minus 16.6355. Now we hit the else condition, which is false because the if condition was true. So I hit step statement and we simply return. We just processed PFX out. Now PY out is going to do the same thing, but it's not going to be forced. So I'll hit step statement. We jump to PY out. So what's the first test in here? First test is if y-axis machine and not mil-cc. So if it's a y-axis machine and we're not in can cycle mode, we're going to output this code here. Now if I test y-axis machine, I don't know, I may have to run it through. I may have to set some of these watches and then run through the posting output completely and restart it in order for them to get updated. Sometimes it's a little buggy like that. But now we're going to process PY out. So I'll hit step statement. It's going to check that. It's not true. It's going to check this. It is true, so it jumps to P check Y. It's going to check this, and it's not true, so it returns. It's going to update Y abs. It's going to update Y inc. So no output occurs. Now we go to PFZ out. By the way, anytime you see F in the post block name where it says PF something out, then it's probably a good bet that the output is forced. So now we go to PFZ out. So it says if absinc equals 0, we know absinc is 0. Why? Because we can look at our watch list and we can see it's 0. So now I can step. I can hit step again. It's going to output Z abs. Here's our Z abs, 0.04. You can see that Z inc is not updated. Now we're going to update Z inc. It updates. We pass the else condition. Now we're going to process PS cool. So, PS cool if V9 coolant. So we hit step statement. If V9 coolant. If cool with speed equals 0, S coolant. S coolant. And now we get the coolant with the speed on. PS cool, so we get the M621 from the S coolant command here because we had coolant with speed turned on. The else condition is not going to be true. We update coolant $, we process string can text, there's nothing there, and we continue on. So we just explored that output. And we saw that this M621 came from PS cool, and in fact that it was the S coolant variable that output it. If I put a watch on S coolant, see I'm getting a server error, so I'm going to put a watch on it, and I'm going to do debug, remove all breakpoints. Actually, I'm just going to do run turbo. So that should finish the output. Now I should be able to reprocess once again, post one more time. So post, debug, check the debug. See? Yeah, there's something funky. We're going to have to reset. So I'm going to close her down. Sometimes it happens. If you edit your post between running different debug sessions, does it maintain your breakpoints and watches? Supposedly, you're supposed to be able to edit it inside the debugger itself. I've never had much luck with that. So my recommendation is no. If you're editing your post in between sessions, shut down and restart. That's the best way to go about that. In fact, you can see here I was having some issues with the debugger. I'm going to completely relaunch it. And we're going to go look for that section again. I want like L tool change. Oh, yeah. So yeah, no, you need to restart it when you make edits. That's just what you gotta do. Clamp off. Film type greater than 1. That's where my breakpoint goes. So I'm going to hit play. We're going to process down to the breakpoint. We're going to go set some watches. Oh, what was it that I wanted to see anyway? So we single step. Oh, S coolant. I think I wanted to put a watch on. Yeah, that's funny that we can't watch a string variable. That's really weird. How about cool with speed? Try replaying it. Try letting it play all the way through. And yeah, that's weird. So some of these variables, for whatever reason, it's not letting me put a watch on. So that's kind of interesting. Yeah, there's some stuff that really is broken, like watch sets. You're supposed to be able to like load in a list of variables to watch from an external file. This is like never worked. Select path for watch files. It's just BS. Like you're supposed to be able to like save this as a watch list and bring it back again, and it's just never really worked. So the post debugger has its place. It certainly is useful for going through and figuring out where output occurs from. But don't look at it as the be-all and end-all of debugging. Okay, there are some other debugging techniques. I think we're actually going to cover them next class because we're going to go a little longer here. Yeah, it is. I mean, it is pretty easy to figure out why something isn't showing up, and it's pretty easy to figure out the logic because in most cases, if sync flag, right? So let me highlight that and put a watch on it. See, you're supposed to be able to do this without getting these stupid server errors. So let me try it. Sometimes you can just try typing it in. So SYNCH FLG sync flag. Huh. Yeah, I mean, there's a lot of stuff where it's not showing up because it is a string select value. It should still show the string value, though. Like, sync flag is a numeric variable. There's no reason it should be giving me a server error. I think, let me try just restarting the debugger. Yeah, I guess try not doing it with a, try to not do that with a string select variable, I guess. I didn't want that, I wanted debug. Because now if I open this up straight, first time, and I just go into my watches, and I do set watch, oh, I don't want that. I want to add a watch, SYNCH, sync flag. See, I can add xabs. Yeah, maybe it's just anything that starts with S, which really sucks. Because if I take year 2 and I put a watch on it, we get a year. If I put time 2 and we get a watch, okay, we get 0. If I grab See if we can find something that starts with X. Subprogram number. Yeah, it won't let me do anything that starts with S. That's so weak. I think that's a new bug, because I don't think I've seen that before. Yeah, dwell works. Huh. I mean, for some string selects, I think... So yeah, we can at least do a search. So here's my SG code target string, which is my string select output, and SG code $sign is the actual selector variable. So if I add a watch to that, as this changes, my SG code output string should change too. Okay. Do we have any questions about the stuff we've covered? Yeah, you can't search in the NC output window. It's really kind of limited for a lot of things, for what you can do with the debugger itself. It's definitely not as full-featured as it could be. But we are at the end of the course for tonight, so we're going to wrap it up and come back for an hour of office hours on Saturday. Has anybody got any questions? Anything we should read before next week? Just continue to read up on the MP documentation. Intro to MP should be like your Bible. You should study this thing, read through the post blocks, variables and strings, MP processing, especially the pre-processing tool table stuff here, entry post blocks, formulas, vectors, and arrays. So all of this stuff is useful to read about. I still got to get together with Derek, so let me hit Derek up and see if we can get an update on what's going on with the website. Unfortunately, I don't do the web development. It's an external developer that Derek uses. I know he does like the website design and builds the course stuff and then hands it off to him to get up on the site. Would implementing an operations list in the NC file require a buffer? Potentially. If you just wanted to output operation information at the header, you can output operation information to the NC file as part of the tool list. So as long as you didn't mind outputting the operation information in the order that you process it in the NCI, it would not require a buffer. If you wanted to be able to sort the data in the operation list, then it might require a buffer. So the buffer would probably only be necessary if you wanted to sort the data. A lot of stuff that we used buffer files for is becoming not as necessary because of this. In the MP documentation, working with enhanced tool tables, this is definitely a good guide to read up on, because working with the new stuff is pretty cool. It eliminates a lot of the confusing stuff that happens when processing the pre-read routine in the NCI. So this is a great document, and it's short. So, it's only 17 pages. Good thing to read up on, to tell you about the new stuff that's coming. How to implement the new enhanced tool table processing in your post. As you read through this, it may sound like Greek to you. And if it does, that's because we haven't talked about normal parameter processing yet. I opened up the parameters a little bit and talked a little bit about the numbers, but we haven't grabbed any data yet. I'm hesitant to show you guys this advanced stuff for two reasons. Number one, it's brand new, and I've played with it a little bit, and it's powerful, but it's got a learning curve to it. So it's one of those things where I really got to go through and write some code and test it to really understand how it works on a personal level, to be able to be comfortable saying, this is how I would implement a tool table with this new code. So that's kind of number one. Number two, it requires making a lot of modifications to the existing post. It requires stripping out, or at least commenting out, a bunch of stuff using the new tool table. So I should say this, not if. When CNC Software releases a new generic post that uses the new P tool table stuff with the new advanced MP processing turned on, I think that's the point at which I'll really start teaching it. Not to say that I wouldn't, if somebody had some questions on it, I wouldn't try to help. I would, of course, try to help you figure out the answer to your question and, how to use this new functionality, because I think it's really cool. But at the same time, it's also pretty advanced stuff. So that's why I say stick to the basics. Learn how the generic posts, because the problem is if you write this new tool table routine, you're going to have to go through all your existing posts and strip out all of the old tool table stuff and rewrite it all. And that's a lot of work. So rather than learning, just about how the new stuff works and then saying, hey, good luck, go, write up a new stuff, I'd rather show you how the existing stuff works first, because it's what's already there, and we can edit stuff, make edits. I know how it all works. I can explain it all real well. And we go through, we make the edits and make things work. I'm all about making these posts work. I want you to get the data in the NC file that you want. And Mastercam's got it. We just got to go get it. So that's what we'll be working on next class and office hours. We'll do some parameter read stuff during office hours. And next class, we're going to be talking about numeric and string variables and formatting. So we'll get into format statements for creating numerical rounding, and format assignments for actually assigning a format statement number to a numeric variable. And then after that, after we talk about numeric variables, we'll talk about strings. And I don't know if we'll get to it Tuesday, but probably Thursday we'll tackle the dreaded string select table. So that'll be something that'll be interesting to get into. String select table is a common function that is used in MP in order to choose a string from a list of strings and output that string based on the modality of a numeric variable. Any questions about the debugger? while you got me here? And if not, no worries, because I'm happy to wrap up class and call it a night, and we can jump into stuff either during office hours on Saturday or next Tuesday. Alright, I'm not getting much on the chat thing. 3:30 Eastern Time, Saturday. That is correct. Yes, sir. Same bat time, same bat channel. In honor of the late, great Adam West. Yep, same invite. I don't know if you guys caught that reference, but Adam West passed away recently. He was the original Batman. And I think they used to say, you know, when they were signing off, see you next week, same bat time, same bat channel. So that was my tribute to Mr. Adam West. Yeah. Yeah, I think the guy was like 88 though, man. Something like that. 80 or 88. Lived a full life. They did a little tribute to him on Family Guy. Yeah. Super swinging guy during the 60s, too. A little bit of trivia for you there. To the Batcave. Yes, sir. Pow, bang, zing. Crash. I loved all that campy stuff. Anyway. Alright, gentlemen. Have a great night. See you Saturday. Yep. Enjoy the rest of your weekends. Halfway done with class, man. So, oh, I see your thing, Zeke. So, cool, man. That'd be awesome. Thanks. Yeah, halfway done with class, and we're getting into the thick of it now. You know, we're going to be just doing more and more post mods and looking at output and variables, logic, processing, string selects, string functions, math functions, learning how to do manipulations, parameters, all that stuff. All right, gentlemen, have a great night. I'm shutting her down. Bye-bye.